Today in pre-cal we talked about how to find vertical asymptotes, holes, and intercepts on the graphs of rational functions. Okay, we're going to start with part A. We're going to do the vertical asymptotes and the holes. I'd like to start with some steps. Number 1, factor the top and the bottom. Number 2, cancel common factors. And if there are some that cancel, those are where your holes are. To figure out the coordinates of the hole, you're going to set the factor equal to 0 and solve for x. You're going to plug x into what remains, and you're going to write that as an x and y ordered pair. That's where your hole will be. Okay, that's it for the idea of holes. Step 3 is to find your vertical asymptotes, so your factors that are left in the bottom are your vertical asymptotes. And just as a reminder, an asymptote is a line, so that'll be an x equals, not an ordered pair. And to find what x equals, you'll set that factor equal to 0. This is a lot easier if I just show you an example in practice. So let's do that. Example number 1, f of x equals 2x squared over x squared minus 1. The step number 1 was to factor the top and bottom. The top cannot be factored. The bottom can be factored into x plus 1 and x minus 1. There isn't anything that cancels out, so there are no holes. To find my vertical asymptotes, I set my bottoms equal to 0. So x plus 1 equals 0 would be x equals negative 1, and x minus 1 would be x equals 1. So my answer would be x equals negative 1 and x equals 1. Let's try another one. Example number 2. F of x equals x squared plus x minus 2 over x squared minus x minus 6. If I factor that, I can of course use my father drives a red Mustang, or I can just see that there are no a's involved here, so whatever multiplies to the last number and adds to the middle number will give me my factors. Hopefully you're getting better at factoring by now. When I do that, I have x plus 2 and x minus 1 on the top, and x plus 2 and x minus 3 on the bottom. I do have a factor that cancels this time because they're exactly the same, including the same sign. So I have a hole at negative 2. Now, my x value I found, because x plus 2 equals 0, would say that x equals negative 2. To find the y value, I'm going to plug the negative 2 in right here. Negative 2 minus 1 would be negative 3. I'm just kind of writing that out to the side. Negative 2 minus 3 would be negative 5, and if I reduce that, it would be positive 3/5. So that is where my hole is in my graph. Now I want to find my vertical asymptotes. To do that, I take what's left in the bottom, x minus 3, and I solve that, so it's x equals 3. And that's my answer for example 2. Let's look at one more of this type. Example number 3 is f of x equals x squared plus 2x minus 3 over x plus 3. The bottom cannot be factored because it's already as simple as it can. In the top, I can do x plus 3 times x minus 1 all over x plus 3. In this case, we have a hole because these two factors are the same. So our hole is at negative 3. Again, that's because I set this piece right here, either one of those. But this right here, negative 3 plus 3 would be 0, so that's where the hole occurs. To find the y, I plug the negative 3 minus 1, which would be negative 4, and get my y value. Because nothing remains in the bottom, on this one there are no vertical asymptotes. Okay, now that we've got a grasp on vertical asymptotes and holes, let's talk about intercepts and how to find them. This is just building on what we just did, so we're still going to factor first, but now to find the first set of intercepts, we're going to set x equal to 0 and solve for y. And for the second set, we're going to set the top factors equal to 0. So if you've been asking, well, why aren't we doing anything with like this right here? We will be now. Let's look at another example. If I take the example number 1, and I'm just going to reuse that one, and I'm going to put it in its form where it's already factored, okay? We already found what the vertical asymptotes are. Now we want to figure out what the intercepts are. To do that, the first step is to plug in 0 for x. So we're going to do 2 times 0 squared over 0 plus 1 times 0 minus 1. On the top, I have 0. On the bottom, I have negative 1. And 0 over anything is 0. If I do the second piece and set just the top equal to 0, 2x squared equals 0, I would divide both sides by 2. X squared equals 0. Square root both sides, and x equals 0. So in both of these cases, I got 0, which means my intercepts are simply 0, 0. Let's look at another case where that does not happen. Looking back at example 2, which now we're going to call example 5, and I want us to look at the factored form of that. So we're going to do f of x equals x minus 1 times x plus 2 over x minus 3 times x plus 2. That was already factored. This is the same as example 2 if you want to put a note out to the side. The first step was to plug in 0 everywhere you see an x. When I do that, I have negative 1 times 2 on the top, negative 3 times 2 on the bottom. And guys, some of you may be seeing the intermediate step here where I can just cancel all those zeros or just cancel all those x's and multiply straight across the numbers. Negative 1 times 2 is negative 2. Negative 3 times 2 is negative 6, which reduces to 1/3. Also, on the front, when we did a whole, we had that one. If I didn't use these, I would have negative 1 over 3, negative 3, which still reduces to 1/3. So that piece comes out the same either way. So that intercept is 0, 1/3. The reason the 0 is in the x place is because I plugged in 0 everywhere for x. To find the other one, I'm going to set the factor that remains up top equal to 0. And when that happens, x equals 1. So my other one is 1, 0. And these two right here are my two intercepts. Again, we don't want to use the whole. We're just going to use what is left. Last thing, part C, I want to just practice putting it all together because that's what your assignment will be like. I'm going to do an example with you, and then I'm going to give you one more problem from your homework just as a bonus for watching this. F of x equals x squared plus 3x minus 4 over x squared minus 1. If I factor the top, I can do x squared minus 1, I'm sorry, not x squared, just x minus 1 times x plus 4, because that would give me positive 3, and when I multiply negative 4. On the bottom, I have x minus 1 and x plus 1. You should notice pretty quickly that that factor is in common, so I can cancel it. Where I can cancel, I have a whole, so my x would be 1. My y would be 1 plus 4, which is 5, over 1 plus 1, which is 2, so 5 halves. My vertical asymptote would be if I set this piece equal to 0, so I have x equals negative 1. My intercepts, if I set everything equal to 0, 0 plus 4 is 4, 0 plus 1 is 1, 4 over 1 is 4, so I have 0, 4. And for the second one, if I set just the top equal to 0, x plus 4 equals 0, x would be negative 4, and y would be 0. And that's my full answer. Okay, let me find a good one to do on your homework. On your homework, I think I will show you how to do number 10, that last one. Make sure that's in your view. There you go. F of x equals x squared plus 2x minus 3 over x cubed plus 2x squared minus 8x. If I factor the top, I have x plus 3 times x minus 1. On the bottom, they have an x in common, so I can take that out to begin with. And then I can continue to factor the bottom piece. So I have x plus 3 times x minus 1 on top. On bottom, I have x times x plus 4 times x minus 2. You should notice that there's nothing that's the same there, so nothing will cancel. I have no wholes. My vertical asymptotes then would be x equals 0 from the first one, x equals negative 4 from the second piece, and x equals 2 from the third. And for my intercepts, I want to plug in 0 everywhere. On the top, I would have 3 times negative 1, which would be negative 3. On the bottom, I would have 0 times something times something. Remember, 0 on the bottom means something is undefined and does not exist. So there is no y-intercept where I plugged in 0 for x. That one won't work. Now, let's set the two tops equal to 0 to get our last intercepts. And that would be -3, 0, and 1, 0. And that's my final answer. Your homework is assignment 13. It's a half-sheet worksheet. If you weren't here today, be sure to pick one up from me tomorrow. Good luck. Let me know if you have questions.